Before we proceed any further, we need to be a little bit more precise about what a polynomial is and introduce some new notation. Now, we know what a polynomial is. We've been working with them for a while. We know one when we see one, but we want to give a slightly more precise definition in order to make our polynomials easier to talk about. So, a polynomial in variable x of degree n is a sum. It's a sum of terms, each of which are a number times a power of x. So each term is a number times a power of x, all the way down to a number times x to the first, and then another number. In that last term, we're thinking, kind of pretend that we've got x to the 0, which is 1. And we're going to ignore that part about 0 to the 0 not being defined for the moment. So the numbers are called coefficients. We already knew that. If the numbers are all integers, we have integer coefficients. If they're all rational, we have rational coefficients. If they're all real, we have real coefficients. And if they're all complex, we have complex coefficients. So if we say some kind of number coefficients, we just mean that all of the coefficients are that kind of number. None of this is really surprising or particularly new. What's really new here is the notation that we're expressing this in. We already know what the degree is. The degree is the highest power of x that has a coefficient that isn't 0, right? We could throw in 0x to the 87th if we felt like it. It wouldn't do anything. In this polynomial, the highest power of x is 3. Our n equals 3. So the degree is 3. We already knew that. The highest power of the variable gives us the degree. In the notation of our definition, we have n equals 3. The coefficients are a subscript 3. That's the coefficient of x to the third. That's 5. A subscript 2, that's the coefficient of x squared. That's negative 11. A subscript 1, that's the coefficient of just x. That's 2/3. A subscript 0, that's the constant. That's negative 7. The way that we would read something like this, we would say A0. Notice also that the 0 is a subscript. That means that it's small and a little bit below the line of text. An exponent is small and above the line of text. A subscript is small and below the line of text. These subscripts just say that these are all different numbers. We're just calling them all A something. The subscripts are just there to keep the distinction between the A's. In our example polynomial again, these coefficients are all rational numbers. Remember, a rational number is something that can be expressed as a fraction. They're all rational numbers, so this is a polynomial with rational coefficients. Of course, every rational number is a real number, and every real number is a complex number. So this could also be said to be a polynomial with real coefficients or a polynomial with complex coefficients. But 2/3 is not an integer. So we could not say that this is a polynomial with integer coefficients. Now, that notation is a little bit weird, but it doesn't contain any symbols we're unfamiliar with. Subscripts might take a little bit of getting used to, but that's not a problem. There's another way that we can write this that's a little bit more compact, but quite a bit harder to read. Instead of writing an x to the n plus an minus 1 x to the n minus 1 plus dot 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 plus a1 x to the 1 plus a0 x to the 0, we can write this what's called sigma notation. This symbol, this funky looking E thing, is the Greek letter sigma. The sigma makes the S sound. S stands for sum. So this sigma notation means to add up all of the things that we get by plugging in the different k's. So a0 x to the 0, a1 x to the 1, and all the way up to an x to the n. And we're going to pretend that x to the 0 is 1 even when x is 0. When we use this sigma notation, we typically assume that x to the 0 is defined to be 1, even when x is allowed to be 0. So all of this is just reading new notation. We already know what a polynomial is. We know one when we see one. But we want to be able to refer to the coefficients. So we'll say an to mean the leading coefficient, or a0 to mean the constant. That's the main reason that we want this new notation.